A really important topic under angles and geometric reasoning is angles in parallel lines. Now, before we jump into the 3 rules and laws that you can use to find unknown angles, the first thing we need to do is understand the components of this. So the first is, what are parallel lines? So parallel lines are 2 lines that are perfectly spaced apart to a point where they will actually never touch. That's how perfectly spaced they are. If we were to draw them infinitely long, they would absolutely never touch. In maths, we use these little arrows to denote parallel lines to show that they're going to go on infinitely and they're never going to touch. The second idea that we need to become familiar with is this line that crosses our 2 parallel lines. It is called the transversal, and our terminology is super important in maths, so we have to remember that it's called the transversal. All right, let's jump straight into the 3 laws that we can use to help us prove angles in parallel lines. I've written an A here because the first is alternate angles. Okay, now alternate angles actually create the letter Z. So to remember this, you just think the first letter of the alphabet and the last letter of the alphabet. Now, alternate angles create a Z. What does this mean? It means the 2 angles inside the Z are always going to be equal. So if I draw a letter Z like this angle here is always going to be identical to this angle here. Okay? Now I've done another set of parallel lines with the transversal here because there's another way that this Z can be drawn, and it kind of looks like a weird looking backward Z like that. And again, these 2 angles here are going to be equal. So you're thinking, why do I need to know this? Because in maths, they may tell you that this angle here is, say, 100 degrees, and they will ask you to find this, and I'll have an algebraic letter there, like an X or an alpha or a theta, and you would say that this angle here and this angle here, they're both 100 degrees because alternate angles in parallel lines are equal. Now, let me quickly write that up. Alternate angles in parallel lines are equal. Now I know that's a lot of words and this is maths, but a critical component of algebra and geometric reasoning is the reasoning component, and you will not get full marks unless you explain to your marker how you knew that this angle down here was 100. To just say it was 100, you'd be risking only getting half of the marks, so just prove that you know what it is, okay? That they're equal. Very critical component. All right, let's move down to this one here, C. Now C stands for, let's not do that one yet. Let's go CoInterior first. So, CoInterior angles. Now CoInterior angles, there's a C out the front, so they make a letter C, okay? Now, we know what a letter C looks like. It looks like this. Now, CoInterior angles are not equal, which means this angle here is not equal to this angle here. The characteristics of CoInterior angles is that they add up to 180 degrees, okay? So whatever this angle up here is added to this angle here must equal 180 degrees. And again, we have a normal C and we also have a backward C there that allow this theorem to work. And again, we're giving a reason to our markers. So we say CoInterior angles add to 180 degrees when in parallel lines. Okay, very important there that we have those proofs and we know how to use them. All right, moving over here, we have another C. Now this C stands for corresponding angles. Now, unfortunately, the C has already been reserved for CoInterior, so corresponding angles actually make the letter F. They make the letter F. Now, as you can see, I have 4 variations for Fs here. There are a lot more versions of corresponding than for the other 2. So let's discuss them all. The first is you have a normal F. A normal F like that. And the features of corresponding angles are that these internal angles here are equal, okay? They are equal. So alternate and corresponding are equal, whereas CoInterior add to 180 degrees. So we have a normal F. We have a backwards F that can lead us to equal angles. Okay, you have an upside down F. last but not least, you can have an upside down flipped F, like completely doesn't even look like an F anymore. There and there. And again, this angle here equals this angle here. All right. Students sometimes get confused whether the angle's in here or on the opposite side of the line. If it was in here or in a C shape, then it would be co-interior. So it's very important that you jump the line, okay, and you do create that F shape with these two branches, creating your angles. Okay, and again, super important to have a rule here. So your rule would be corresponding angles are equal in parallel lines. Alrighty, I won't write that one up. It's identical to this one, except that your proof here is corresponding angles, and it's very important that you learn how to see these, because there's going to be multiple questions where they're not going to say to you, find the co-interior angles, find the alternate angles, but those are going to be within more complex shapes. Alright, as always, try a few